or like this. It just means that they never ever cross. And we can determine if they are parallel lines by their slopes. So if we know the slope of one is equal to the slope of the second line, then we say yes, they're parallel lines. Now perpendicular lines, they meet at right angles, and they have 90-degree angles here in the corner. And we know that to determine if they're perpendicular lines, we know that the slope of one has to be equal to the negative reciprocal of the slope of the second one. What this means is if we have a slope of, let's say, 2/3 for the first slope, m1 is 2/3, then the slope of the second one would have to be -3/2. This is the negative reciprocal. So that's what that means. Whatever the one is, the other one has to be negative, and the numerators and denominators are flip-flops. So let me show you another one. If we had -4, then the other reciprocal, slope, excuse me, this is m1, and this would be m2. The other slope would have to be positive. It would have to be the opposite sign, so this is positive, and it would have to be a reciprocal of each other, which would be 1/4. So that's how we find those. If these are the same, if these are opposite like these, not opposite, negative reciprocals, then they are going to be perpendicular lines. Not to be neither, it means it does not meet one of these two statements here or criteria, and they would cross like this. They could be two lines with one point, but they cross very close, or it could be the exact same line. They would not be parallel or neither, or perpendicular. They would be neither. So let's use this information that we just learned and figure out number 14 from our packet. It says to determine are they parallel lines, perpendicular lines, or neither. So how do we determine if they're parallel, perpendicular, neither? Find their slope. So I got to find the slope of each one. So I'm going to separate these out, and I'm going to say 2x plus y equals 4. And I'm going to find the slope of this one, and then I'm going to find the slope of the other one. So this is this first one here. So how do I find the slope? The easiest way is to solve for y. So I'm going to subtract 2x. Y equals -2x plus 4. What's my slope of this first line? m1 equals -2x, because it's whatever is in front of this x. When you have y by itself, that is my slope. Sorry, I put an x down there. It does not need the x. The x is not part of the slope. Okay, so this is my slope for this first one. Now, if my slope of this second one is the exact same, it's going to be parallel. Let's see what it is. So here, take this one down here, and I go x minus 2y equals 14. I'm going to solve for y, so I'm going to subtract x from both sides. -2y equals -x plus 14, and I divide by -2. Y equals 1/2 x minus 7. What's my slope of this other one over here? Yep, m2 equals 1/2. So I'm going to write them over here so we can see them a little bit better. We have m1 equals -2, m2 equals 1/2. So they're not the exact same, so they're not parallel. I know they're not parallel because they're not the same. So are they perpendicular? To be perpendicular, one has to be positive and one has to be negative. Yep. One has to be, the numerator is a 2, and the other one, the denominator is this, is a 2. So yep, these are what we call perpendicular lines. Okay, let's do another problem. Okay, here's number 16, and I just rewrote these so that I didn't have to write them twice. But this first line is x plus 5y equals 7, x plus 5y equals 9. So if we want to find the slope, we gotta solve for y, and I'm going to subtract x from both sides, and I have 5y equals -x plus 7, divide by 5, y equals -1/5 x plus 7/5. m1 equals -1/5. Now I'm going to come over here, and I'm going to divide subtract both sides by x. 5y equals -x plus 9. Divide by 5. Y equals -1/5 x plus 9/5. m2 equals -1/5. So these have the exact same slope. They are parallel lines. So we would say that they are parallel lines because the slopes are equal. Now I'm going to go on and talk a little bit about this over here. Remember, what did we say this part here was? These are the y-intercepts. and we'll see in a little bit what we can do with that. But these two have the different y-intercepts. They have the same slopes but different y-intercepts, and they're parallel lines.